geotrig, this is lesson 10. Lesson 10, guys, has information that you guys have been dealing with before. You've seen it before. You guys will see this again. And it might not be in this class. Well, you will see it in this class because this is lesson 10. We're going to get through about 70 or 80 lessons. You will see this come up in every lesson probably after now. But, guys, I'm working with my pre-calc kids just currently, and we had to do this stuff. We talked about vertical lines. We talked about slope. We talked about perpendicular lines. We talked about creating line equations. This stuff comes back up next year. You can't just say, okay, I'm going to do it for just this week, and then say forget about it. Because guess what? You did this in Algebra 1, you did this in Algebra 2, and now you're doing it in geotrig. If you haven't noticed, you do a lot of things that way in this class. This will be your third or fourth time of seeing this in your math career. But yet, you'll claim you don't know how to do it. So the question is, stop doing what you always do, which is just learn it for the moment, forget about it. You need to sit back and say, what is the meaning, what's the concept of this, so I can put it to long-term memory. And so the first thing we're going to talk about are line equations. So our line equations, guys, we have a horizontal line. A horizontal line is a line that has a slope of 0. Wait a minute, we're talking about slope. Slope is actually one of the definitions or things that we have to figure out. But a vertical line, let's go to a vertical line first. We all have seen vertical lines. First of all, let's back up. That's a horizontal line, give or take, yes? Everybody's okay with the horizontal line. It goes straight across, kind of like these things here. But a vertical line goes the other way, yes? Vertical lines go this way. And a vertical line has what kind of slope? Does anybody know?
It's 0.
Not 0, that's horizontal.
180.
It's not 1.
90.
Not 90, not 2.
It's 1.
No, it's not 1. We already said that.
Infinite.
Not infinite, the other side of that.
0. No. Oh my God.
How about it doesn't have 1?
Okay. So it's 0.
It's not 0. 0 would be 1. Guys, the slope is what we call undefined. And we're gonna realize that here in a second when we talk about what is slope. Also, maybe before we move on between horizontal and vertical lines, we should probably also state which variable is associated with which one. What kind of a line equation is a horizontal one? Which way do you make your tick marks? What axes? Go horizontal lines. Guys, if I made my graph.
That's why you should sit in each.
Those are my tick marks on which axis? They are all horizontal. So it's y equals k.
Oh, and x equals 8.
Yeah, oh yes. And vertical, wait, hold on. Yes, and x equals h for a vertical line. Does anybody understand why I would say h and k? We haven't talked about it necessarily this class, I don't think.
We definitely have talked about it.
We have done h and k?
Oh, no, not in this class.
Not in this case, but you have seen h and k's before. Circle, it's the center of a circle, h and k. It's also what we use for our vertex of parabolas or absolute values and any other thing or equation that we start to translate left, right, up, and down. Okay? So that's why h and k come into play. So y equals 3 is a horizontal line at y equals 3, or 3 up. X equals 5 is a vertical line that goes through x equals 5. All y values are 3 or all x values are 5, that type of thing. What is slope? No, not the equation. Okay, well, how would we say slope? Equation's next. Slope is what? Rise over run. We sometimes call it something slightly different than that before we even get to the formula. We'll talk about formula next. Other way around. It's the change in y over the change in x. The y's are your rise, right? Your height component, your delta. Triangle in math, and it's as theta is the circle with the line through it. So that's a change in y over the change in x. And if you are so inclined, we could use the formula, which would be m equals.
Y or MS plus B.
No, that's slope-intercept form of a line.
Y equals M equals.
Guys, you should know the slope formula.
Why do I not know this? Hold on. Stop.
It's y squared minus.
Stop. Everyone. It's x1 minus yeah.
Now, guys, could we do y1 minus y2 over x1 minus x2? Yes, that'd be perfectly fine as long as you stay consistent on the top and on the bottom. That's the change in. The change in y's is the final minus the initial. The final minus the initial for x's is x2 minus x1. That gives us the slope every time. There's a big note here, and the note says, any non-vertical line has a slope, and it also has a y-intercept. It doesn't matter how small or how large the slope is. It's not straight up and down, so therefore it will have a slope, and it will eventually, no matter where you make your first point, it will have to run through the y-axis, which means you have a y-intercept. You guys kind of getting this idea? That, yes, okay, think of this right here as my center of my graph. I can create a line way down here, right? That line there, I'll take it away. I'm just using this for a demonstration. This line has a slope because it's going up and over, yes? And if I keep going, eventually it will cross the y-axis way up there. Can you guys see that? So it doesn't matter how steep it is or not, it will eventually have to cross somewhere on the y-axis. That's what it says. We go into parallel lines and perpendicular lines. Parallel lines are special because why? They'll never touch, okay? Parallel lines, we'll say, never intersect. Be more mathematical, right? Never intersect. But they also have what? Same slopes. So they have the same slopes as each other. So if I told you that line 1 has a slope of 4, and the next line is parallel to it, it also has a slope of 4. Is that the same thing for perpendicular lines? No. Guess what? Perpendicular lines will intersect. At what? Ooh. No, not always at 0, 0. I heard someone possibly say it. They meet at what kind of angle? Right angles. It's a right angle. It's an angle symbol. So they meet at right angles. What kind of slopes do they have? Recall from your memory. They're opposites, yes. more than that. Opposite
Second.
Reciprocal.
Oh, that's
opposite reciprocal slopes, guys. Which means if one's positive, the other one is negative. Example is 2 is the first slope. Your next slope would be negative 1 over 2. Opposite reciprocal slopes. Is this all coming back? I hope it will soon. First thing on the slide is positive slope, then negative slope, and zero slope. Let's just show everybody, show of hands, positive slope line. Go.
positive.
Positive should be going from left to right, should be going up. So it goes like this. Negative slope,
Down.
going downhill. And zero slope is, yes, that horizontal line. Easy enough. Hopefully you guys remember those. But I heard this said earlier, slope-intercept form. Y equals mx plus b. Now, what do certain parts mean?
Y is
So, some of these variables mean things. What does m mean again?
The slope.
Slope. B.
The y. Y-axis.
Y-intercept.
Yeah.
So, if I gave you a slope and a y-intercept, really easy. We like those types of problems because I can write the line equation quickly, efficiently. But that's not what always happens. Sometimes I give you a point and a slope instead. Therefore, you will default to point-slope form. What is point-slope form? Who remembers this one?
isn't it
What?
Y equals
No, y minus.
Oh,
Okay.
it's y minus y1 equals
totally
Y minus y1 equals what? Yeah, that's it.
Y minus y1 equals m times the quantity x minus x1, where m is still slope, and x1, y1 is your point that was given to you. So if I was given a point and a slope, I would be able to put it in here. That's point slope. And then solve for y, and I would have slope-intercept form. You should be able to go from point slope to slope-intercept form without a problem. Now we're going to put to practice what we just learned. Some of the things, we got to put it all together, guys. I want you to write the equation of the line given the following information. Two points. Something that we don't have or need would be a slope and a y-intercept. Does it just explicitly tell us that? No.
But
So that means I actually have to figure things out. If I'm given 2 points, it's really easy to find the slope using the slope formula. But here's the problem, guys. Which one's point 1 and which one's point 2?
it doesn't matter. But the thing is, if you put the 2 minus the negative 3, you have to put negative 3 minus 1.
Yes, okay. It does not matter which one's point 1 or which one's point 2. I'll give you a hint. I generally choose the bigger numbers to be point 2 because I'm always subtracting point 1 from it. And that hopefully will guarantee me to have positive numbers. And again, we like positive numbers better than negative numbers. We're less likely to make mistakes. Now, but unfortunately, the problem up here has positives and negatives in both of them. So in this case, it really doesn't matter. Let's just do this and say this is 0.1 and that one's 0.2. So when I say that, that means that I should be able to go right above it and say x1, y1, x2, y2. That's basically all I'm trying to establish. Therefore, I don't make a mistake when I go to write it out. Showing my work consistently all the time. Something you guys, I think, are lacking in your homework, which lacks on the quizzes. You need to make sure you follow the process. So, start to fill it in. What is y2? Negative 3 minus y1. 2. x2 minus negative 3. Now this is where another sticking point that trips up a lot of students. If I subtract a negative, you have to add the positive. Two negatives create a positive, and so the slope of this line happens to be negative 5 over 7. Our next choice, ladies and gentlemen, is to decide which point up there I want to use to put into which formula. Which formula do I want to use? Point slope. Y minus y1 equals m times x minus x1. Oops. That's coming up next, guys. Don't worry. Which one you guys want to use for point 1? Can we just use point 1 for point 1? Could I have used point 2? Can I use point 2 for point 1 instead? Yeah. It's the same line, guys, through the same 2 points. So it'll work. It's going to work. So I'll just use point 1. So it's y minus 2 equals negative 5/7 of x minus negative 3 again. So that minus minus makes a plus. Hopefully everybody sees that. And now, if I want to put this into slope-intercept form, I need to distribute the negative 5/7 and then add 2. Distributing through, guys, one step at a time, would be negative 5/7 x. What's a negative 5/7 times 3? Negative 15/7. Everybody okay with that? Last move. Thanks for the participation. Of add 2. Now, the problem is that when I put this 2 together with the negative 15/7, they need to have common denominators. We don't have common denominators. So I need to take the 2 and multiply what?
7.
And over 7, right? Because it has to be 7 over 7 and multiplied by 1. So what is 2 times 7? So it really comes out to adding a 14/7. If I add a 14/7 to a negative 15/7, I'm negative 1/7. So the equation happens to be negative 5/7 x minus 1/7. You're done. Next problem. The next problem says, hey, we have this point out in space of negative 5, 5. And we know that there is a line going through it, but it happens to be perpendicular to the equation of 3y plus 4x equals 2. Does anybody know what that equation form is called? This has a form. This equation is a certain type. It's in what form? Standard form. This one's standard form. We will talk about that hopefully in a little bit. But if I want to know the slope of a line, the easiest form to recognize it in is the other one. Slope intercept, right? So, guys, the first thing I want to do is solve this for y. So bringing 4x to the other side. Everybody's okay with that? We've done that a million times. The last move on that part is divide by 3. Now, we could simplify this, because that's the proper thing to do. And so when I do simplify this, the 3's cancel. I get y equals what? Negative 4 thirds x plus, no, 2 thirds. Remember, each piece gets divided by the common denominator of 3. So, what's the slope? It's negative 4 thirds. But that's the old slope. We need to be perpendicular to that, so we change it. What's the new slope going to be? What's the slope going to be? Positive and flip to 3/4. New slope, new point. I'm going to pause it. You write the equation now.
What about the x?
The x is part of the old equation.
Okay.
So you got to figure out the new stuff. Again, you have to go through this point. Here's your new slope, which would be perpendicular to this line. So therefore, put those two together using point slope.
Oh, okay.
Go. So here we go. We got to finish the problem. We got to write down the formula we're going to use.
Okay.
Always. What's x1, y1?
X1 is the negative 5, and then the Y1 is the 5.
Is a 5. Slope is,
The 3 over 4.
so y minus 5 equals 3 over 4x plus 5. Can we make that leap, guys?
Yeah, because,
And put it as a plus 5 right away?
yeah,
Why is that?
because it's a minus and a minus, and you know that it's plus.
Close the screen. And so, y minus 5 equals 3/4 x plus
15 over 20.
15 over
4.
4.
Yeah, no.
And then I can add 5, but when I add 5, that's not common denominators. So common denominators, 4 over 4, which is actually 20 over 4. So it ends up being a 35, yes. So y equals 3/4 x plus 35 over 4, and you are done. The last thing I want to talk about is, what if they don't give you a set of points, they just give you a graph? There's a couple options, guys. Yes, I'm liking what I hear. I can find slope, guys, by tracking between 2 points, my rise and my run. That would be given a slope. I could look at the graph and say, hey, it crosses at 7. That's awesome. I could also go for the fact that I could say that's a point, and so is another nice point here at negative 3, 0. So I could do negative 3, 0, and 0, 7. Find the slope. Put it in point slope formula. You're done. That's awesome. Also, guys, what kind of equation is this blue line? It's a horizontal line. They all are what form? Y equals. In this case, y equals? 2. Y equals 2. And you be done. Homework, guys. Lesson 10 is page 80. This is day 1. 1, 2, 5, 6, and 15. Have a great day.